Bismillah ar-Rahman ar-Rahim. I'll try to do this, which is 7.1, the area of a region between two curves. Yeah, what's the idea? The idea is very simple. If you have a region, this is a region between two curves. This curve 1 and this curve 1. So I have a curve above the other curve over that region. So what will be the area? The area, and they have it from x equal a to x equal b. Okay, so you can think of it like if I put like a strip here. So I want to do it all the way, so from A to B, and I want F minus G, since F is bigger than G, above G. Okay, so it's a bigger than that. So I have F of X minus G of X from A to B. That will be the area, which if you can think of it, it will be the area under the curve of F, which is, yeah, minus the area under the curve of G. Okay, so as I said, with this strip, so they have it from A to B, and the upper function minus the lower function, the top curve minus the bottom curve. So this will be the area. That's it. Now, other than that, you need to do the calculation, finding the area. So the most important in this section, you need to graph the function. You need to graph the function, so you can see it easily. Yeah, example, easy example. Y equal x squared plus 2. That is x squared plus 2. This is the function, or this is 2, and y equal minus x. And they want it from where to where? From x equal 0 to x equal 1. To x equal 1. So I'm talking about this area. Talking about this area. So it will be the area. Will be the upper function. It's from 0 to 1, and will be f of x, and will be g of x. So it will be integral from 0 to 1, f of x, the upper function. Let me write it in details. This is the first example. 0 to 1. What is f? Is x squared plus 2 minus g of x, which is minus x dx. So now it's just a matter of doing an integration. So you need to do the calculation for the integration. Yeah, that give me what? Just to be sure about the calculation. 0 to 1, I have x squared plus x plus 2 dx. That give me x cubed over 3 plus x squared over 2 plus 2x. Yeah, which is 0 to 1, which is easy to do. That will be 1 over 3 plus half plus 2 minus 0. Ignore it. So I have what? 5 over 6 plus 2, which is 12 over 6. That will be 17 over 6. Another problem. 2 minus x squared and g of x equal x. But he did not give me from where to where. So what's new in this one? Let me graph it. Let me graph the function and see what will happen. This is 2 minus x squared. So this is x squared. This is minus x squared. I need 2 minus x squared. So it will be something like this. That will be my function f. And what is g? G is this one. Okay. If g is this one, wait a minute. I'm talking about which area? This area. This is the area bounded between these two graphs. And this is G. This is F. This is G. Okay. So I need to find what? I need to find this point. Actually, I need to find out what is X here. And also I need to find this point. I can find these 2 points. It's the intersection. Oh, no, not this point. Sorry. I need to find this point and this point. So I need it up to here. Huh? I need it up to this one, which is this one, the x values. And I need it up to here, yeah. somewhere. Okay, so I need the intersection point. How to find the intersection point of two curves? Just equate them. If x equal gx, so that implies 2 minus x squared equal x. Yeah, so I have what? X squared plus x minus 2 equals 0. Factor it, x plus 2 times x minus 1 equals 0. So I have x equal minus 2 or x equal 1. So this is minus 2 and this is 1. That means what? My area will be the integral from minus 2 to 1. Now I get the values, huh? Where I need to find the area. It's from here until here to cover all the area. And what is the upper function? It will be f of x, which is my upper function, minus g of x, which is my lower function. So now it's a matter of integration. So that will be integral from minus 2 to 1 f of x, which is 2 minus x squared minus x dx. Do the calculation. That will be 2x minus x cubed over 2 minus x squared x cubed over 3. Sorry. This is from minus 2 to 1. Be careful with the calculation. That gives me what? 2 minus 1 over 3 minus half minus 4. Yeah, minus 4 plus 8 over 3 minus 2. Okay, that give me what? I have minus 6 plus 2, that give me 8. This one I know it's 5 over 6 minus 8 over 3. Yeah, do the calculation. That will be what? 8 minus what? Yeah, 6, that make it, yeah, okay. 2, 16, that will be minus 21 over 6. That give me, what? Over 3, that will be 7 over 2. This is 16 minus 7, 9 over 2. Just a matter of calculation. Okay, it's 9. Find the area bounded by this on this side, by x equals 0 and x equal 1. Okay. So I have the function. Yeah. Always you need to think about the graph. This is e to the power x, and this is y equal x. They want the area where x 0 and x equal 1. So I'm talking about this area. This is my area. So if you do like the strip, this will be the upper, and this will be the lower function. And then so the area will be the integral from 0 to 1 of the upper function. Yeah, let me do it quickly. E to the power x minus x dx. Now it's just a matter of calculation. That give me what? E to the power x minus x squared over 2 from 0 to 1. That will be e minus half. Yeah, since I have space, let me do it here. That will be e minus half minus e to the power 0, which is 1. So it will be e minus 3 over 2. That's it. Another problem, which is, yeah, it's a little bit open, but let us, yeah, make it, what they want, the sine and cosine curve intersect infinitely many times, bounding regions of equal areas, as shown in figure this. But this is what will happen in the figure, okay? I have, this is cosine, and this is the sine. The sine will go up to here, then it will go down, then it will go back. He wants this area. He's talking about this area. So he's talking about this area, which is repeated. It will be repeated. Okay. Now I need this point. Also, I need this point to know the x values, huh? No, these express. So the integral from where to where? Okay. So how to find these 2 points? I need to check the intersection point. So I need sine equal cosine. When sine equal cosine, for sure I have x equal pi over 4 or x equal 5 pi over 4. You can do it in another quadrant, another cycle, but I think let us do it in the first cycle. It will be easier. The same thing. So the area will be pi over 4 to 5 pi over 4 of what? Now this one is what? I have the upper function. This is the upper function. Will be my sine x. The lower function will be my cosine x. Okay. So that will be sine x minus cosine x dx. This is the way we construct the integral. Now we'll do the calculation. Integral of sine is minus cosine. This is minus sine from where to where? From pi over 4 to 5 pi over 4. Yeah, now we need to be careful with the calculation. That will be what? 5 pi over 4 is in the third quadrant. So it will be minus square root 2 over 2. And the same thing with the sine. Now minus with pi over 4. Oh, wait a minute. This is minus, huh? So it will be minus. This is minus, so it will be square root 2 over 2. And the same thing with the sine. And in this one, I have the minus in the formula. That will be minus square root 2 over 2 minus square root 2 over 2. Since pi over 4 in the first quadrant, everything is positive. And just the minus sign is here, the minus sign in the formula of the integration. So I have a square root of 2 minus square root of 2. So I have 2 square root of 2. That will be my answer. Find the area of this, the enclosed between the parabola and this, and the other parabola. Yeah, this parabola, I need to, if you remember, I need to find the vertices to graph this parabola, or I can do it. I took minus x minus common factor. I want to do it by completing the square. That will be easier for me to rewrite the form, to write the parabola in terms of vertices. Huh? Okay. So I have minus x squared minus 2x. I will add 1. I add minus 1, so I add plus 1. So it will be minus x minus 1 squared plus 1. Okay, so I have this parabola, which is y equal x squared, which is y equal x squared. This is the parabola, easy one. Call it y1, and I have y2. Y2 is what? Is the parabola where I have 1 and 1. 1 and 1 is part of this parabola, so I have the point 1 and 1. And it opens, it's 0, 0 is part of it, huh? So I have 0, 0. And this is like this. This is what I'm talking about. This is the area I'm talking about. Okay. And it goes from where to where? Very clear, from 0 to 1. From 0 to 1. So the area will be from 0 to 1. The upper function, which is this one, minus the lower function, which is only x squared. Dx. So now it's a matter of calculation. So you have what? You have integral from 0 to 1 to x minus 2x squared dx. Okay. That give me what? X squared minus 2x cubed over 3 from 0 to 1. Yeah, easy one. That will be 1 minus 2 over 3, and the answer is 1 over 3. Okay. I think that explains it. Okay. All the problems we did before, we have a function minus a function. We have only one area. Huh? We have one area. This area. We don't have different areas. Now, what about if I have different area? If the function goes up, then goes down. So the like in this portion of the graph, this is G is above F. But in this one, Yeah, no, this one is F. F is the red one, and G is the blue one. So in this one, F will be above G. This one, G is above F, and then I have F above G. So to fix that, you can't do it using the absolute value. So I need the upper minus the lower. Okay, and then be careful about this point, where the function will be written either F minus the absolute value, F minus G, or G minus F. So for sure, I need this point of intersection. Okay, we do a problem. Find the area of the region bounded by the curves y equals sine, y equals cosine, which is easy to graph. Be careful about it. This is sine. I can do it complete sine, and this is cosine. And then, yeah, cosine will do something like this. To here. Okay. Yeah. This is pi, but cosine is -1. Yeah. This is pi, this is -1. What I care about is only between 0 and pi over 2. This is 0, this is pi over 2. So I have this area and this area. I have two areas. So this one call it A1, and this one call it A2. So what is the area which I'm looking for? It will be from 0 to pi over 2, absolute value, anything now. Sine minus cosine, who cares? F minus U or G minus M, but the absolute value will be the same. Okay. Now in A1, now by the way, what is this point? This is an important point where sine equal cosine, where the change, huh? Yeah, where I have F over G or G F above G or G above F. Okay, sine X, that means X equal pi over 4. So this point is pi over 4. Okay, so if X between 0 and pi over 4, if X between 0 and pi over 4, then what happened? Then cosine X would be greater than sine X, above sine X. Huh? Yeah, like in this period, I have cosine is the upper function. If X between pi over 4 and pi over 2, then it's the opposite. I have sine X above cosine X. Okay, so now I split the integral into two parts. This is the first problem, because this is very important. I will do it in details. Plus pi over 4 to pi over 2. Absolute value sine X minus cosine X dx. Now in this one, sine minus cosine will be negative. So I need to, since cosine is more than sine in this period between 0 and pi over 2, here it's positive. Since I'm dealing with pi over 4 to pi over 2, where sine is above cosine here. In this period, sine is above cosine. Okay, so that will make it what? This one, I have from 0 to pi over 4, cosine minus sine dx. And in this one, so I'm doing it in details. This is the first problem. That will be sine minus cosine dx. Okay, now do the integral. Now it's a matter of calculation. Integral, that will be sine x plus cosine x from 0 to pi over 4 plus, what is this? This is minus cosine x minus sine x from pi over 4 to pi over 2. Okay, sine pi over 4, that is square root of 2 plus square root of 2 minus what? Sine 0, which is 0, minus 1. Okay. Plus, here I have what? Cosine pi over 2, which is 0, minus 1. Okay. Minus, this is the rule of the integration, minus square root 2 over 2, minus square root 2 over 2. Yeah, be careful with the minus plus. That will be square root of 2 minus 1 plus square root of 2. So the answer is 2 square root of 2 minus 2. Yes, that will be my answer. I think it's very clear that I have curve, they intersect many times, I need to be careful. Okay. Yeah, sometimes it's not easy to graph the function. So sometimes he gave you the graph. Okay. Now this is very clear. In this period, G, this is G. G is the lower one. G is this one. This is G. So F, this is F, and this is G. So in this area, F is above G. In this one, G is above F. And also he gave me the values. This is will be minus 2, this is 0, and this is 2. So the area will be from minus 2 to 2, absolute value f of x minus g of x. But that is from minus 2 to 2. Here I have f is above g between minus 2 to 0, sorry. Minus 2 to 0. Yeah, up to 0. In this, I have in this period, I have f minus g. Let me write it right away. It's wasting time. That will be 2x cubed minus x squared minus 10x. Yeah, details, okay. F of x minus g of x dx. From 0 to 2, it will be the opposite. Now g is above f. So it will be g of x minus f of x dx. That gives me what? Here, now it's a matter of calculation. Minus 2 to 0. Yeah, f minus g. Let me do it here. F minus g or g minus f. Just a minus sign difference. I have 3x cubed minus x squared minus x squared gone. That will be minus 10x minus 2x. That will be minus 12x. Yeah, so that is my function. So it will be f minus g. That gives me 3x cubed minus 12x dx. G minus f, it will be the opposite. It will be 12x minus 3x cubed. Okay. Yeah, it will be 12. Yeah. That will be plus from 0 to 2, 12x minus 3x cubed dx. Now do the integration. I have 3x to the power 4 over 4 minus 6x squared. This is, I need to do it from minus 2 to 0 plus the opposite. 6x squared minus 3x to the power 4 over 4 from 0 to 2. That give me what? 0, 0, مع السلامة, 0, minus. Now with the 2 minus 2, yeah, it will not make a big difference. Minus 2 to the power 4, that is 16 over 4, so that 12 minus 24 plus. This is will be 24 minus 12 minus 0. So I have what? 12 plus 12, which is 20. Yeah. So the answer is 24. Okay. Some regions are best treated by regarding to deal with it as x as a function of y, not y as a function of x. Yeah, we can do this. So do the integration, or like I'm doing the strip, like I'm doing this. Okay, so I'm doing it from C as y values, from C to D, and it will be the right function, the function on the right minus the function on the left, where this one will be bigger. So I have f of y minus g of y. I'm doing it from C to D, where I'm dealing with the y values, and this will be dy, not dx. Okay, so this will be the strip. Okay, let me do an example. Find the area enclosed by this line and the parabola. As I said, the best things to deal with such problems is to graph the function. If you graph the function, then you can see it. And I will tell you exactly why we need to do it this way. And it's better to do it using in terms of dy, not in terms of dx. Okay, this is the parabola. The parabola is what? This will be 2x plus 3. So my point is minus 3 and 0. And the parabola is open to the right. So this is a parabola. And they have y equal x minus 1. At 0, it's minus 1. At 0, it's minus 1. So I have function like this. Oops. This is the line. Okay. Now, if I do it in terms of dx, yes, here very clear. I have this is above this. I need to be careful also. This is not the problem. When you try it in terms of x, I need the square root. That will make it a little bit complicated. Now, up to here, yes, this is above this. Here, I have what? In this part, I need to split the function into two parts, where y is plus or minus square root 2x plus 6. So here I have y equal square root 2x plus 6. Here I have y equal minus square root 2x plus 6. So I need to consider this, because now I have two different areas. I need to split the area into two parts. This one part, and this is another part. However, this is why I'm doing it dx. If I'm doing it dy, always I have this function is to the right of this function. So no need to split it into two parts. But now I need to deal, I can have it f minus g all the way, instead of doing two parts and two parts, two complicated parts, because I need to change the function into square root 2x plus 6, and this one minus square root. Yeah, but now no need to do all of this, because it will be just a function of, let me do it like this. So it will be f minus g as a function of y, not a function of x. So now let me write everything in terms of x. So here I have x equal y plus 1, because you notice I need to write the function x as a function of y, and the same thing for the other one, x as a function of y, and I will deal with the y values. So I need the y values, which is, now what are the y values here? The y values here are, let me check the intersection point, and then we'll try to see the y values. And there I have what? Y squared minus 6 equal to x. So I have x equal half y squared minus 3. So this is called it f of y or g of y. Yeah, what I wrote, this is g the parabola. So this is f of y, and this is g of y. Okay, now I wrote it in terms of y. Now I need to find the intersection point, so I equate these two equations. I have y plus 1 intersection points equal half y squared minus 3. Okay. If we do the calculation, that what? Multiply by 2, 2y plus 2 equal y squared minus 6. So I have y squared minus 2y minus 8, which is y minus 4 times y plus 2 equals 0. So I have y equal -2 and y equal 4. So I have the integral from -2. This is the point where y equal -2. And this is the point where y is equal to 4. So I have the integral in terms of y now, -2 to 4. And always I have f, which is the line, minus g, f minus g, since f of y as a function of y, minus g as a function of y, dy. So I'm dealing with it in terms of y, not in terms of x. Okay. And they have, this is function of y, x equal, and this is function of y, x equal. So just now plug it, -2 to 4. I have what? Y plus 1 minus half y squared plus 3 ty. That give me what? Just do the calculation. Yeah. I have minus half y squared plus y plus 4 ty. That give me minus half y cubed over 3 plus y squared over 2 plus 4y, and all of this from -2 to 4. Yeah, still wasting time doing the calculation. If we do the calculation, plug the numbers, fractions, deal with it. Let me do it. It will be what? With the 4 minus half, 64 over 3. Yeah, that give me what? 32 over 3. Or, yeah, let me say minus 64 over 6. With the 2 here, it will be plus 8 plus 16 minus. With the 2, you have what? Minus 8 over 6. Let me write it, minus 8 over 6. 2, that give me plus 2, minus 8. Yeah, no need to waste time. That will be, if you do the calculation, let me give it to you. That will be 80. Check it. I'll do this problem, then summary, then I will stop before I go to more a little bit complicated problems. Okay. Now find the area of the region bounded by this graph. This. Okay. So this one, now let me graph it. I have x equal. So this is, it's the easy line. 0, it's at x equals 0, y is -1. So it's the same line we did before. But this one is the parabola to the other side. So I have parabola going to the other side. Now let me write the parabola first, I think. Let me grab the parabola first. That will be, yeah, still with 3, huh? Not minus, yeah. With x equals 3, y is 0. So the vertex is 0 and 3. Okay. No, 3 and 0, I mean. Yeah, 3 and 0. Not 0 and 3, 3 and 0. The vertex. And it's opened to the left. And then I have this line. Okay, so I'm talking about this area. Well, if I do strip this way, it's okay here. Here I have another area. Also, I need to deal with it with the square root. So that will make it a little bit complicated. So instead of doing that, I will do it as a y. If we do it as in terms of y, I need only one way. I need only one area. So the area will be I need now the points of intersection, like what we did before. I have 3 minus y squared, y equal +1. This is the intersection point. That give me what? Y squared plus y. I took everything to the other side. -2 equals 0. So I have Yeah, y plus 2 times y minus 1 equals 0. So y equal minus 2, or y is equal to 1. Okay, so I have the integral from minus 2 to 1. Now, which one is the to the right? The parabola to the right. The parabola minus the line. So I have 3 minus y squared minus y plus 1. This function minus this function. dy. I'm dealing in terms of y. So that gives me what? Minus 2 to 1. I have minus y squared minus y plus 2 dy. Okay, do the calculation. That gives me minus y cubed over 3 minus y squared over 2 plus 2y. This integral from minus 2 to 1. If we do the calculation, we'll save time. That gives me 9 over 2. That gives me 9 over. Okay, so now I have these three cases. Yeah, you need to be careful. This is a summary of what we did in this section. Now, this is the regular one where I can do the strip like this. So I have f minus g, the integral from a to b, from a to b. The same thing for the y, but I deal now from right to left. The bigger will be to the right, and then the smaller will be to the left. So the bigger, the one to the right minus the one to the left, dy. And from the y values, from c to d. Okay. And also, if I have different intersections. Now, sometimes G is above F, sometimes F is above G. So that I need the absolute value. I need to check these intersection points, and then I need to see when F is above G or G above. So I deal with the integral. These are the three cases for the area, and I think we did an example in each case. The most important thing, you need to graph the function. Yeah, we need to see the graph of the function, so we can know which one is above the other one, and also point of intersection. Sometimes we need to find. So I think this is enough for this video. Then I will do more problems later. Yeah, let me stop the video since it's explained the basic idea of this section. Thank you.